Hello, here with Pierre Massa.
Pierre Massad, yeah.
Massad, yeah, sweet, from Sentry. And what is
Yes.
like your title and whatnot? Like
Staff engineer.
staff engineer, cool.
Yeah. And so I lead the EAP team, Events Analytic Platform team, which is basically the responsible. So my team is responsible for storing every event in order to run analytical queries on it.
Yeah, makes sense. And the, I guess like maybe start with like a brief history of just like all the like kind of events analytics platform at Sentry, like what was there before.
Yeah, so some people before me built a service that we call Snuba. Snuba is our basically API to kind of query stuff at Sentry, or query analytics, do analytic queries at Sentry. And we use ClickHouse for the backend. We build around that, like its own caching layer, some ways to do allocation policies, like to kind of control how many bytes can be scanned by some queries, and because we're multi-tenant, and so it's important to kind of like be able to control those kind of things. And yeah, we Sentry at its core is errors, so reporting errors to us. And so we had one ClickHouse cluster for errors, and then we started to have like transactions and more tracing information, spans, profiles, uptime checks, and stuff like that. And so we started creating like one cluster per data type. So it started to evolve into a place where like we now have like a 10 different cluster, 10 or 12 different clusters, something like that. And well, there's an operational burden linked to that. It also means that because they're in different clusters, we cannot like join those two things together very easily. So yeah, we can like trying to find like a way to evolve from there. And last year, our new CTO, Dave Rosenthal, came on. And the first thing he said is, we're going to create a big store that stores all the events that can be related to each other based on a trace ID. Because like technically we sell context around errors. So we want to gather as much context around an error so that you can fix it fast. That's basically what our product is. And so he said, like, hey, we're going to build a platform to store all of this in one giant cluster, and we're going to be able to query one event type in relation to another event type, and we're going to hide all the problems behind an abstraction that we call the RPC, so that product teams don't need to care about the details of how it's implemented. Because before they had to make their own, like we had like our own little query language, and so they had to know that query language in order to do this, and it was not that easy to use. And we started seeing at some point that some teams were trying to optimize the query language.
Sure.
It's like you make your own query language, but some teams are like optimizing on by doing things like, instead of passing like an array with IDs, they would pass a string calling, but the query would also call like a parse function inside, so that you send a string so that our API doesn't have to like parse the array of many IDs. But then the ClickHouse cluster would end up reading that and be like, oh, I need to parse that string in order to, and so it would become like the part of the inquiry. You're doing it wrong if you get 2 points like that, for like, so we kind of had to redesign that and make it like make it different. So
yeah. I think I heard at somewhere, like different podcasts or different resource, that like even in the initial implementation of like the ClickHouse, it was just kind of okay, well, all the existing like OLTP style like queries don't really work. Okay, so now let's like move to like the OLAP style, like no select star, but like we don't really know how to optimize the performance, so we just like kind of try a bunch of stuff, and then like once it gets optimized, we just like start high-fiving each other. And so now it's
and so now we're kind of like having an API that is kind of, it's giving you enough building blocks, low-level building blocks, to be able to select like your like events in a certain way, run some aggregation, but very select aggregation. Our API in the backend like manage like generates the actual query that will be run, and so we kind of manage like if we want like to pack performance optimization, transformation, or if we want to like store part of the data, we decide where we store the data. So at some point we might want to like store the data into a different data store or a different place to kind of answer some type of query before, to be able to answer like some type of query faster. And the product doesn't have to care about that. The product tells me like what they want, how do they want it aggregated, and they don't have to care where it's stored, how it's stored, and how to generate the query that will extract that.
Yeah, yeah. Is there, I guess, like one thing like all of the product teams at Sentry were sort of having to think about is like the query plan, even though like I'm not sure how much Snowball like has a query plan, if that makes sense. Like, like when people talk about Postgres, they're fighting the query plan
Yeah,
constantly, but
ClickHouse is kind of dumb in that regard. It basically it looks at okay, so the problem that the product team had to kind of face before is like, okay, so what type of data do I need to store? How to organize my sort key? How to organize my query? Because like, ClickHouse doesn't have like it has some like indexes, but they're pretty limited. Bloom filter index, it's not exactly the same as like a Postgres index. And so everything is depending on how do you lay out your data on disk and in what columns. And so if you're going to load like 20 columns every time you select something, well, it's a bad idea. Don't do that. If you make if you just make your sort key by I don't know, random ID, you might also have a bad time every time you do a query by timestamp. And so they had to understand this. They had to kind of like care about the performance of that sometimes. And what often we would see is they would tailor that to a very specific use case, and as soon as the use case would change, turned out it's not stored on disk the right way. And so that's kind of like our first like span storage. When we transitioned to like storing span information, we were storing span with a group ID of spans very early in a sort key. And so as soon as we wanted to stop doing that and do aggregation in a different way, we couldn't, because the sort key kind of prevented us from doing that. And so that's why having an abstraction and having a team responsible for that and having an abstraction was a good idea, because like now they don't have to care about that. We ask them to give us like a timestamp, some list of attributes, a trace ID, and stuff like that. We organize that. We sort that on disk so that it's organized by timestamp and stuff like that. We allow them to query via timestamp and trace ID and whatnot, but it's planned for that. And yeah, it's a little more restrictive in the sense where well, they always have to pass us give us a timestamp. It's not good for like a single row access type of thing and stuff like that. But at least they don't have to care about all this. They don't have to care about the schema that how it's stored in the backend, how it's stored in the database. We have our own like little bucketing system to kind of store. We basically kind of made a key value on top of ClickHouse. A little unorthodox maybe, but it kind of works pretty well, because our schema by definition, like we have custom attributes from customer and all that, we do not know our schema. So we do have some optimization for like Sentry specific attributes, but most of the time we don't really know what people want to query on, want to aggregate on. And so yeah, that was very helpful to kind of tell the product team that they don't have to care about all this. And I think the benefit of that is now they can launch a product like much faster, because we already have this platform that is built. We already have like a mental model of like how things are stored, and they also understand that they don't have to care about the rest. They just like shove a bunch of data in our face, and we do queries, and they know we have a protobuf contract. We have a protobuf contract on like how things are, what type of query they can do and stuff like that. And as long as we don't break that, everybody's happy.
I was looking a little bit through the like changelog. So Sentry now has, I think, a new insights page, new logs products.
Yeah.
There's Seer. I'm not sure if that's related, but there's just like a lot of stuff has like been launched this year, and like I'm just guessing just a part of
Yeah.
the
So
created.
we first launched like the new Trace Explorer that leveraged spans on the API. That was the first product. We kind of built the API for that at the beginning because that's the use case I was talking about. In early 2024, teams were like, well, we want to change the span product to be something else. We couldn't because the storage was very specific. So that's when we kind of decided like, hey, we need a new storage. Then Dave came on and Dave was like, we need to platformize and do everything around like a big platform around like a Trace ID. And so we put two and two together and we're like, hey, we can have this repository of data. And so then logs was really like we created a new item type log. And so that was it, one commit, one line. And they started ingesting logs and that was easy. And metrics, we created this new metrics product in less than 5 weeks. We started like end of October and we're already in open beta with it. And it's the same thing, it's like everything goes into the repository of data. The only thing the product team has to do is like a good UI, good UX.
Yeah.
And the platform provides enough features that they don't need us to implement new things. And so far, I guess I would say.
Yeah.
But that helps like launch product faster. We don't have to provision like specific cluster for that, for specific cluster for to handle the load. We don't have a new ingestion pipeline to do. It's you drop a message on a topic and then you can query it right away.
Do you find that there's like kind of two questions I have from that, but do you find that a lot of the product teams have just been able to like buy that product easily? So like if you imagine you've split like Sentry into two companies and like the platform teams like AWS and whatnot, like the product teams are still like very happy. They don't like have a ton of like requests, or is there like somewhat of a loop in that?
So what was funny is at the very beginning they were not very happy because it's always this kind of project. It's like, oh, it's going to be a big project. It's going to solve all your problems. It's going to be like, and people had an understanding of ClickHouse and they knew it was limited in some ways. And they were like, oh, I'm sure we're not going to be able to do this or to do that. And like, to an extent, it's true that the what we did is more generic, needs to be more generic. It's like the schema is more generic, the way we store things, like so there's less optimization baked in, but at the same time, we also created like so much more, like we just use more nodes. It's the biggest cluster that we have at Sentry. And like there's just more compute dedicated to that in order to kind of like cover up like the lack of optimization, I would say. And so, instead of having like a very specific schema that is tailored to your usage, that is faster and use less resources, we decided to be a little more generic, a little less tailored to a specific use case, and just be able to scan faster, okay, to scan more. And so we do run more compute for a given use case, but at the end of the day, it kind of like works out because, well, you have additional feature for that. And, like the fact that you can relate item type together and so like you can do joins basically and stuff like that. That's really powerful for our product team. So a lot of skepticism at the beginning. And then also, we needed to build the RPC. We needed to build like we built in like some extrapolation features. We built in like a downsampling. Well, it's a little bit of the same thing, but like so that we can guarantee like a query will be run in under like 8 seconds, for example, for like a 30-day query, because we know how many events you sent us, and we're like, okay, you sent us that many events, so it means we need to target like a different tier. And so we're going to go to a different tier where you have less data, so faster because there's less data to scan. And now, because we also ingested like the client sample rate and the server sample rate, we're able to extrapolate that back to what roughly would be the actual real volume without scanning as much data. So it kind of gives us like a lot of flexibility like that. And those are features that the product team were like, hey, actually it's pretty cool because performance are fine. I don't have to care about performance that much. The contract is already written, and so like the API is fixed for all the products now. You don't have to kind of rewrite or re-implement like new queries or new stuff. It's like the item type is the same shape for everything. So they built the one product team can like build like their own API to spend that. And now all the other product teams just use that API to serve directly in the front end. Like they don't need to make their own stuff, their own special stuff. So that's kind of nice. And yeah, they started to be very happy with that as we managed to demonstrate that it wasn't vaporware. You know, it's like we built something, it's big, it's kind of a lot of data, and it gives you the kind of like performance you want for your aggregations. Because what really counted, like product team at Sentry never really wanted to like, we had a strategy for a while where we would like dynamically sample your data at the server. So we would be like, hey, you send us this, we think it's important, we're going to store it. And when we don't think it's important, we extract some specific metrics, we store that into a different like a cluster, and then we would try to make sense of that. But the problem is like, well, product teams wanted more flexibility than this because like maybe they want to have access to all the samples, but storing all the sample and scanning all the sample, it's a difficult problem, right? And so that there was a lot of tension linked to that. Um, and so when we came up with that project, it was like, hey, we store all the samples and you can aggregate whatever you want. They were kind of skeptical because they've been told forever that we couldn't do that because of speed, we couldn't do that because of cost. And so they were like, okay, well, we'll see if you can actually do it. Sometimes, you know, we tend to sell a big product and then kind of like, as we find like some corner case or like some issues with the cost or stuff, like to reduce the scope. Well, it didn't happen this time. We delivered on what we said we would, and cost is also good for us, kind of worked for us. So um, thanks ClickHouse.
Yeah, yeah. Well, one thing through a lot of that, I think the thing that I've like picked up is like predictability. Like it is both very predictable for like the infra team like managing everything, but
Yeah.
also, you know, even if the performance is like slower for the product teams, right, it's still actually like pretty predictable. You know that like
It's yeah. It's important. Like we do have like SLOs around like how many seconds we can spend like for a query. So instead of having like potential queries that would like maybe time out after 30 seconds, well now we can say like, hey, if you use our dense, like if you use our normal mode meaning like either like we're gonna decide, we're gonna route your query to a tier like either full fidelity or like a downsample tier with extrapolation. It's like if you use that, we guarantee you that you're going to have a response and some data back. And then we cannot take care of that. And you know, before that, it was on the product team to kind of like make a query that wasn't design a storage and make a query that wasn't like timing out. And so they needed to know a lot of things. And you know, there was like we were like the team like to help them, but there's always like it's difficult. It's like the product usually moves faster than backend teams or like a platform teams, and so there was always a little bit of tension because then performance problems arise, and so who's responsible? The product, the backend. So that's why this platformization of things, having a strong abstraction and a strong like boundary where we can guarantee like, hey, if you like if you give me like a if you like if you give me just a list of fields and what event type you want, I guarantee you that I'm going to answer in like 8 seconds. This was very helpful to kind of like have the trust of the product team.
mhm. Also, I think at some point, and like, were people on your platform team kind of going like to like each product team, like team by team when there was issues versus kind of like having some sort of like API that like both people were buying into, or like what did that look like?
No, nobody was like before or now.
Before EAP, yeah.
Before EAP, no, it was more like a the platform team, like the analytics team, Snuba team, like we had different names, but let's say Snuba team, the team that built Snuba the service. We basically made tools so that product teams could build their own data store, and so
Oh,
that was more like the mandate. So we had like ways to like create your migration, create your like your cluster, add that easily. There's some configuration, and we kind of acted as a consultancy, be like, hey. Um, uh, you're responsible, you manage the cluster, you're responsible for it, but if you need help, we are here to help. And you know, it's nice, but also like I think product team had a hard time with that because at some point, like you're gonna need to specialize. You know, like when you're a small company, everybody needs to do a little bit of everything, understandable. But as Sentry grew, and you want to create like more and more products, and you want like you don't really want to spend time like figuring out infra or handling like query issue problems or stuff like that. Like, and you know, again, before Sentry only had errors. As soon as we started to add like more and more product, then you start realizing that all the teams need to redo the same thing over and over again, like the same features, same rate limiting, the same optimization. And at some point, it's like, well, maybe we don't have to do that. Maybe we do a stronger platform. Because Snuba already was a platform, but it was just like even lower level and kind of like really make your own adventure. And so we transform this view, we just elevated the platform a little bit, be like, hey, we're going to impose some boundaries, some like constraint, not that much that you cannot do, it cannot be flexible enough for you, but we're going to impose some boundaries so that you don't have to care about a lot of things. And we took back a lot of responsibility for like managing the cluster and stuff like that. And we guarantee performance, and that's it.
Yeah, yeah. It's interesting too because I think I also heard at some point just the thing that like drove Sentry to Snuba was, you know, you guys just having like I think the tag store and like the metric store and all of this was like in Postgres, and it was just all like a bunch of like replicated data. Like the migration from like old Postgres Sentry to new ClickHouse Sentry is like 52 terabytes or something like that to like 2 terabytes or something like that because there's just like so much like duplicated data.
I wasn't there at the time. I wasn't like doing
Sure.
that at the time, but like yeah, it would,
Yeah.
you know, like putting like specializing teams and putting them in charge of some things at the expense of a little bit of flexibility, I think is a good strategy to make things work inside a bigger and bigger company.
Yeah, that makes sense. Um, one other in terms of like operating now, like the new EAP community, I think like one kind of interesting thing to start with, it's like somewhat low level, is just like the spreading out like custom attributes just kind of across call. It was just kind of like a fun thing to hear about.
Yeah, so the problem that we had is like usually you want to put like a specific attribute in specific columns because it's obviously going to be the fastest. But the problem is like ClickHouse doesn't really have a feature like that. At least at the time, it didn't really have a feature like that. And we have a shit ton of like custom attributes that are sent by customers. And right now, before we had like tags, context. You couldn't like aggregate by or query your context or search on context. And so it wasn't a great product experience because the people like using our SDK had to choose like, okay, what is the tag? What is the context? How do I use one? Is my data better in the tag or a context? And there was a lot of distinction like that. And also every time you wanted to add a new field, even internally, like a new Sentry field, we needed to add a new column, store that, and we had some issues. All that because like, oh, that's just how we're doing. So EAP, in order to solve that, we decided to make like we wanted like one column to like store everything. The problem is like then your rows can become very big. You can like if you store like 100 attributes into something and you want to scan that column, it needs to load the whole row for that column. And when you're interested into one specific attribute, it's not that great. So at the time, we didn't really have any solution. So we said like, hey, we're going to create like many columns for a given type and just kind of spread attributes around. And turns out it works pretty well.
Yeah, yeah, and many types being like specific ClickHouse types, right? So I think there's like a like float type.
Yeah, we have a float type, string type, Boolean type. And now we're adding like an array type. But basically we cover like the scalar types plus, and now we're going to cover like arrays because like we added like a OLTP endpoint to ingest like a open telemetry data, and because they allow you to send like objects and arrays, we kind of need to support that as well. But yeah, I mean, we have buckets. We let you store. We randomize. We hash, the attribute name into a bucket, and that's it. And so the little story too is like now ClickHouse has like a JSON type where you can store your data, like, and it's a third JSON type that ClickHouse had, because the first one was just not that great. The second one like had a flaw or something, and they removed it, and that's like the third try. So we've been looking at that for a while. Back when we started, in like, it was in a version of ClickHouse that we didn't even like could use in our testing, um, because it was like barely released, or we use like the Altinity fork of ClickHouse, and so it wasn't in there and stuff like that. So there was a lot of things, but even and so the cool thing with that type is it creates a column behind the scene. You want to store an attribute, it creates a column behind the scene to kind of store your attribute into a specific column. So then when you come back to like scan this specific attribute, you're only going to scan a column with your data in it. So the problem is like, it's still the same thing. When you're like in a custom attribute environment like us, well, we don't want to suddenly have like an unbounded amount of columns, because it creates like files on disk, and it gets kind of weird, even if it's like not that big, because there's only one customer that is gonna, you don't want that. And so we couldn't use that, and that's where the bucket, at least the bucket kind of limits our systems of buckets, they limit the number of like files and columns that you can have, and it kind of helps manage performance.
Yeah, that makes sense.
But recently, in 25.8, they released an update where they're also going to use a system of buckets. So you can like configure a way to say like, hey, I'm going to use like up to 10, 100 columns or whatever, and then it's going to be stored into a shared column, and started. So that was a JSON type. It's like you define like a number of paths, and then you had this shared column at the end. But now this shared column is going to have a number of buckets, and it's going to round robin. It's going to like spread that your attributes around, kind of like we do for our buckets. And so I think one optimization we're going to do at some point is we're going to adopt that JSON column, and we're going to have like very small number of like columns, like maybe only one column or zero column that by default, and we're just going to count on that like shared bucket, and
yeah,
ta-da.
Yeah, it's very interesting. I was just like, you just have some like amount of sane limits, or just like some amount of limit in general that you just like get.
Yeah, you cannot plan what the customer is going to do to your. We don't know what they're going to store, what capacity or whatever. And so from a platform perspective, we need to put in place this like limits so that we can control like. And to be honest, like I care less and less about what the product teams are doing with the store. I don't really want to necessarily understand that, because we took the party of like, it's going to be generic. It's just good at scanning a lot of data, and so send me a lot of data. Like, before it was always like, oh, we're planning to have this amount of volume, and so you need to plan the store based on this. And like 9 times out of 10, they either have like less traffic or more traffic, but it's never right on point. And so now I care less, because I have my allocation policies. I know that I'm not going to grow my disk so much. I can plan like I have the cluster is shared between a lot of data type, and so one data type doesn't impact as much the scale of the rest. And so again, like mutualizing that into a platform like that is very helpful. And so we impose like some constraint, like the size of what you can store, the number of attributes that you can store, maybe stuff like that. And but that's it.
Yeah, and then even like one layer above, you also like for your queries as well, like you limit the amount like per customer, right? Making sure they don't go over.
Yeah, allocation policies and
yeah. I guess can you talk about like, I guess like what is the future of maybe like those policies, because now you have like all of this kind of like rich metrics data just for yourself internally at Sentry to see like what customers are doing, and maybe it's like I think you mentioned a little bit like we were talking before about potentially like splitting customer traffic to like different clusters or cells, or yeah, what are the like, even if they're unfinished thoughts, like what are the thoughts there for?
No, so we are evolving. So specific to allocation policies, before allocation policies were like, okay, you're limited to 20 connections per second. That's it. And that's no reference. It's just like somebody decided it's 20. Now what we're evolving that towards is more like, okay, we're going to look at the health of the cluster, if it's running hot, if there's you know enough memory to execute that or whatever, and we're going to basically like dynamically modify your allocation to be like, hey, the cluster is doing nothing. You want to run a BigQuery? Okay, be my guest, and we're going to run the BigQuery. And if after that the normalized load like kind of spikes too much or whatever, we're going to be like, hey, maybe the next ones we limit them a little more. And that's kind of like our evolution of like allocation policies is like we're going to tend to be more dynamic about the level, because why wouldn't we run a query? I talked about these downsampling tiers and like our capability to like look at less data in order to um, give you an answer. But like maybe we can, if the cluster is doing nothing, instead of limiting you, we can say like, hey, scan tier one, just use more threads to scan the full fidelity tier. Something you do usually, more threads like that you usually don't have access to, but um, and you know get your high fidelity data, and that makes of a better product experience still in less than 8 seconds.
Yeah, yeah, yeah. There you go. There's
That's the idea. It's always like the predictability, but doing the, hey, scan more data because the cluster is not that busy is it's always a good thing.
Hmm. Yeah, I listened to a talk at the test night from Uber where they have this for MySQL, like a throttler that just like every
Yeah,
MySQL client, yeah, can have like, hey, this specific query is like this specific level, and it kind of like just figures out what queries to throttle and like accept at a specific time. It's like very like that pattern is like also just like nice to have here. In terms of like which, there's like other systems other than just like kind of the stuff running on ClickHouse. I know you guys have like some amount of like workflows and stuff like that. Like, does that also like what does your like kind of like task system or workflow system look like? I think I read at like somewhere that you guys have like Arroyo, which is like built on
oh yeah,
Kafka, even though that's more for like the entire streaming stuff, but that's also like another set of like
we don't have a task system, to be
okay.
honest. Like, I mean, we have task broker now. I guess that's like but it was built as a replacement for our salary workers.
Yeah.
um, I guess that's like our task broker. Arroyo was like the library to let you build consumer more easily. Uh, Building a Kafka consumer turned out is pretty difficult. Even with Arroyo, it's still difficult because the semantics are like not that easy to kind of fully understand and fully grasp, especially when like some things are like just very Kafka specific, like rebalancing or stuff like that. Like what happens during all that. Like so, we want to but at least Arroyo was helping to like make your own consumer more easily than just starting from scratch. But now we want to kind of go again, platformize the whole thing, where like product team wouldn't have to even think about like, oh, I want to implement a consumer that's going to read from Kafka, and so I have my read from pull from Kafka function, I have a process function or whatever. We kind of just want them to like have a piece of code, a function that is run their code, and just be like, run it. And so we're working on that. Task Broker was really trying to just be a replacement of Celery that doesn't use Celery. Because Celery, it's like in-memory queue, and well, we had a lot of incidents where like we would fill up that in-memory, we would fill up that memory, and then things would kind of crash and it would kind of be weird. So Task Broker is just that, but on using Kafka instead of whatever Celery is doing.
Yeah. Is there, like let's say you just like ran down the entire like celery path. Is there like a way to like distribute the like work properly, or is it just again like one of those it's like not really
Yeah, yeah. I
predictable?
mean, the thing is like, yeah, you can distribute the work properly, but at some point, if you have something that blocks, you need to buffer somewhere.
Oh, I see. Yeah.
And
Mhm.
we had too many incidents that we ended up like buffering somewhere in Celery. And so we built mechanism of back pressure. So we buffer on Kafka and all this. But for some reason, like Celery was always a pain point, and it's we had like we could keep investing into Celery and stuff like that, or we can just like decide like, yeah, we switch to a different system and we make it more reliable. And we decided to switch to a different system.
Yeah. Yeah. Entirely based on Kafka.
Yeah.
What are your in terms of like so like the Kafka ClickHouse kind of pairing is like very classic. I guess now
Yeah.
it's like changed maybe a little bit, but What are
No, it's like Kafka, Flink, or Spark,
yeah.
ClickHouse, or like some sort of data store. And then now you're starting to have like Iceberg in there, and
Mhm.
like I don't know, Apache Doris or whatever. Like
Yeah. Yeah. What are your thoughts just about like Iceberg in general? It's like something that's so like Sentry is somewhat like backend agnostic, I think, or I guess Snuba it's like a little bit harder. But yeah, like what are your thoughts about like doing that kind of thing? Because you have like a pretty big analytical workload. It does run, I guess, like
but that's the evolution of our like platform. So EAP, we built that on ClickHouse. We were under like some timeline to kind of like develop that, and so we kind of use our usual techniques of like ClickHouse, block storage, boom, done. And so now we're switching to like what it would be the next generation of like our EAP, and I think that involves like what we just talked about, like using Iceberg to store or to store on object storage, using Flink to kind of like power our like consumers to dump into Iceberg, and then we hope to keep using ClickHouse to be our query engine but this time instead of like looking at disk-based files on disk, we would just kind of like scan Parquet files on object store for the same thing.
yeah, yeah.
So we're working on that right now.
Yeah, yeah. It is the like kind of classic pattern right now is the like SSD, like you have like a node with SSDs, and then there's some amount of well, I guess for this workload it's a little bit different, right? Because your ingest can just go straight to object storage, provided it's not too high of a
Yeah,
latency. But
exactly. I mean, there might be a way where like we kind of buffer like one day or a few days of data into like a very fast like a SSD based like a cluster. Um, so yeah, we might still use like a more classic way to like for very short queries because we have a system of alerts, and so we need to ingest some data and like then we have a lot of queries on that data, and so that would be perfect to like put that on SSD and just bury the cluster in like because it's very usually it's like short queries like over like 24 hours, and like it's not something we really want to go to like object storage object store for. So we're imagining something a little hybrid like that, where we would have like a one ClickHouse instance that do that data, aggregate on like on these attributes very easy, and then it gets TTL to like object storage or something like that.
what I think you like mentioned a bit in the like pre-show, just like trying to stick with as many technologies that you feel like the organization can learn as well. Like what um
Yeah,
yeah.
I don't think like we we're a big user of ClickHouse. I don't see that changing anytime soon. We learned a lot. We know how to kind of use it, manage it. Same thing for Kafka. Um, yeah, we're probably not going to change too much. Like, we're not like we at the end of the day, we have a product that we want to run, and ClickHouse is just like a mean to that end. And so we tend to not introduce like technology that much because also like ClickHouse is still evolving and in a good direction for us. So I don't see us needing something else because there's like if we wanted like ClickHouse is kind of new to that like query stuff on object storage, and so like there's not really like a good way to do that, or it's barely starting to have a good way to do that. Some other like project would probably have been better for that, like maybe Apache Doris, like some stuff like that that were meant to be on Kubernetes, use the object storage and stuff like that. But imagine you would have to like relearn all the kinks of that. So I think we prefer using ClickHouse, and we're going to keep using ClickHouse.
Yeah, yeah, makes sense. The are you guys on Kubernetes for any of your orchestration stuff, or like what does that part look
Yeah, I
like?
mean, besides the ClickHouse cluster and like the Kafka cluster and like things that don't really auto scale, everything else on Kubernetes.
Okay, yeah, that makes sense. Wait, can you repeat that first part again? So sorry.
Well, I mean, Kafka cluster is like
Oh yeah.
you don't auto scale a Kafka cluster, so that's on VMs. ClickHouse, same thing. It's like there's not really a way to auto scale, so it's on VMs. Zookeeper on VMs. and literally everything else is on Kubernetes.
Gotcha, makes sense. And then it's still like I think 3x3 replicated for like ClickHouse at least. Um, like your ClickHouse like clusters like has 3 replicas, I think.
Yeah, with 3 replicas because we're in 3 zones everywhere.
Yeah, makes sense.
But some cluster have like 15 shards, some have like 4 shards, some have like 1 shard. Like then it's kind of varies.
Would you ever? It's like a very odd, random, like not in my like agenda question, but like, would you ever like do any? I guess it's just a little bit too hard right now to do orchestration with ClickHouse because again, you just like need it's like block storage where you just need that disk attached. But
I
like,
mean, we would do that when we manage to move to object storage.
yeah, I was gonna,
As soon as we manage to put our data on object storage and we can query that with ClickHouse, yeah, we would totally do that.
yeah. So it's just a factor of it being like extremely stateful in
Yeah.
that way. Yeah, makes
Yeah.
sense. Cool. Good to know. Let's find some other questions. There's like one or two other things. One other interesting thing that I thought of earlier is like the way that you guys use ClickHouse, uh, not only in the like uh or one thing I wanted to cover is like maybe like multi-tenancy, like managing traffic like across yeah, we can do that bit. I guess to finish the thought I had was like it reminds me a lot of like DynamoDB. You know what I mean? Where I think the thing you were mentioning earlier about having like the sort key, right, is like when you guys were like, you know, when product teams would initially start, they'd like set a sort key, it'd be the wrong sort key, you want to change it. I remember being at like my first startup job using Dynamo, and it's just like, okay, our primary key is like the wrong thing, we're like a bit screwed. All right, it's like very hard to spread traffic
Yeah.
thing, but
I mean, it's kind of like the same idea.
yeah.
Um, but yeah, now the sort key is still the same. It's like it's difficult to change, except it's made in such a generic way that at the expense of like having to scan more data in order to find your stuff. But at least I'd rather dedicate like data on that than workers to threads to scan than to limit the power of like product teams. Turns out it's cheaper to spend money on compute than it is to slow down a product team.
Yeah, sure. Yeah. Not only in I guess like maybe additional manpower you need to like keep the product teams happy, but also just in limiting their revenue growth, right? You know, like you have all these new product lines that you can charge for. So yeah.
Yes, well, that's above my pay grade. They just asked me to do something fast.
Sure.
I did something fast. That's all.
Yeah, you were mentioning earlier, like before the recording started, that now things have been going well. You've been adding more customers, and now like it seems like the limit is not just on your like analytical like platform. It's now back over to the transactional side of things. I don't know if that falls up under EAP, but
No, it's not really a responsibility of the AP. No, so now we are gaining customers, and we're kind of like getting to a point where like our current US environment is kind of big, and so we're gonna have to either solve some like uncomfortable like scaling issues with our Postgres database, or stop accepting customers.
yeah,
Difficult,
yeah,
difficult task.
sure.
And so yeah, our strategy with regard to that would be to kind of like start creating new environments to direct new traffic to, so that we kind of cap the growth of like the older environment. And so we're starting to work on that, but creating cells of different multi-tenant multi-tenant cells, and so we can split instead of scaling ad vitam aeternam like one thing and having to solve like per service like individual problem or scaling issues, individual scaling issues. We decide to cap the growth and be like, hey, we're just gonna create a new environment and start pushing everything there. And you're still gonna have like some scaling to do inside those scale, depending on like if the customer is successful or whatnot, or maybe you have a churn and like some customer leave and you can scale down. But the idea is you don't have to like take your Postgres database and have to shard it in every environment, because like now you just vertically scale until you think you reach the max, and you just like create a new cell and put people in a new cell, and that's it.
Yeah, makes sense. The yeah, that'll be exciting. I mean, it's like a very fun problem to have. You know, like I think even like
Too many
Figma.
customers? Yes, it's a
Yeah, yeah,
phantom.
yeah. Like Figma hit this point as well. It's like you can scale up so far, and then it's like, all right, now do a bunch of like sharding stuff, which is cool. What are, I guess, just other in general like fun problems or things that you've gotten to work on at Sentry while I read my
Well, I
notes?
think the fun problems are now going to come from like the AI stuff. So well, we launched a bunch of products in 2025. I think we're not going to launch as many products next year, but we we're going to focus a lot on like AI and our like doing our code review bot and our Autofix that we call. And so the idea is like Sentry is a big repository of all your like performance data. So we have your spans, we have your logs, we have your metrics, we have your errors, and so we are in a unique position to give a lot of context to an AI tool in order to find the right fix and fix it the right way. And so that's what we're going to invest in, and that's going to be a very nice and very fun, I think, year for the team that takes care of that. From a platform point of view, we're probably going to have to build like new platform things to kind of like abstract that and not just have this team use that platform. I'm thinking about maybe we're gonna have to throw like a vector DB in our tool set, or a new way to graph DB to kind of contractualize more stuff like that. I'm not sure, but and so those are like the fun challenges, the fun thing that we're gonna have for 2026. A lot of resources are gonna be dedicated to AI.
Yeah. I think I heard somewhere, I'm not.
AI that, by the way, is gonna be interested in like querying EAP and all the data that we have. And so I'm expecting like a big amount of traffic coming our way because of like all the boats. I mean, the autofix bot that we're gonna do, like they're probably gonna have to have access to all the data and query that in different ways and query much more data.
Because you can just kind of hand it EAP the same way that
Well,
you
yeah,
can
but
to your platform.
that the thing
Yeah.
is like we can just like we could just end it, but then they need to make the understand like we're gonna hand it to them. Like it's gonna be easy, but it's gonna put some load and it's gonna like so that's also part of why we want this object storage, because like then we can dedicate like a pool of workers that are gonna query object storage for that for those bots, and we can separate that from like actual customer like query and manage the traffic so that everybody's happy and everybody has an answer in 8 seconds or less.
Yeah. Once all the data is like in ClickHouse, you know what I mean? Like no use to just like replicate it. Now more to like more VMs that just have like more disks.
Yeah.
Excuse me. Yeah. Yeah, that'll be very cool. I mean, you know, as sort of like a general trend stepping out of the engineering stuff, like a lot of like platforms are going this direction, or a lot of tools where it's like you start out very niche, you kind of like grow in that vertical. I was like listening to a different podcast where it's like even like Workday and HR platforms are just like, yeah, like we're gonna start exposing more of our data out to like agents and whatnot because it's just like very beneficial for us, right? Even if you know
Yeah, because the agents are going to use the data in new ways that you don't necessarily like have the product bandwidth to like do. And like ChatGPT will book your flights for you at some point, or like and so in order to like Sentry might not be competitive to like create their own models because we don't have the expertise, we don't have, but we still have a big amount of data to like be able to give context to a bot, and everybody's gonna have their preferred like a model to use or whatnot. Maybe you're gonna use that inside Cursor, maybe you're not gonna use it. Like so, what we can do though is we can like give you access to all your data to like and present a good context in order for you to like use it to fix your stuff.
Yeah. I guess as a final thing, like I think one thing I've heard somewhere about Sentry as well is like, again, you have this like massive pool of data. The other goal is to like make it like more opinionated in terms of like what Sentry gives you. Is that like mostly AI stuff, or is there also just general things that you guys have seen, or it's like, oh, like we as engineers at Sentry have needed this kind of like opinionated product, and so now it's like time to give that over to other people. And it's like a lot easier because it's just a new kind of EAP kind of query.
Yeah, but I mean, our opinions are very good, so
Sure.
at least listen to us.
Yeah. Yeah.
No, but I think in general, like giving access to data to people,
Mhm.
they'll find like creative ways to like use it.
Mhm.
And so we
Yeah,
need to prepare for that era of like having to, you know, present the data that we have to many more agents.
cool. Do you have any Sentry callouts, a Sentry hiring? What is next up?
Sentry is always hiring, especially my team. My team were hiring. So if you want to come do cool stuff at Sentry around like analytical storage, and we 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 recruit.
There you go. Awesome. Alrighty. Thank you so much.
Yeah, you're welcome.
Sweet.